Welcome to part 2 of trigonometric translations. And in part 1, we reviewed this. If you remember, we're dealing with two equations. One is y equals a, the sine of b times x minus c plus d, and y equals a, the cosine of b times x minus c plus d. What we have here is, if you remember, the amplitude is always equal to our a. B is the number of cycles in 360 degrees, or 2 pi radians. C is our shift horizontally, and D is our shift vertically. And if you remember, what we do is the first thing we want to do is find the midline. So if you remember, the midline is always equal to the max plus the min divided by 2. It's really the average. And in this case, if we look at the max, it's at 1. If we look at the min, there's a min, all the minimum values are at -5. So it's simply the max 1 plus a -5 divided by 2, and that's a -4 over 2, which is a -2. So we know that our midline is at -2. And that also gives you our value of D. So that's D. And we will write that down here. D is equal to -2. And we'll sketch in the midline. Midline is at y equals -2. So let's sketch that in. I always find it easier to see what's going on when I have the midline sketched in. And the next step would be to find the amplitude. And if you, some of you know that the amplitude is simply the number of units above and below the midline that the graph goes to. So in this case, if you notice, there's a distance of 3 units from the midline to the maximum point, and a distance of 3 units to the minimum point. That would tell us our amplitude is 3. However, the formula for it is, for the amplitude, it's simply the maximum value point minus the minimum point over 2. It's the absolute value, because we don't talk about a sign here. We're just simply talking about a value. So we're not talking about direction. And I didn't mention that in part 1. So the maximum point is 1. The minimum point is -5. 1 minus a -5 is 6. 6 divided by 2 is 3. And sure enough, our amplitude is 3, which gives us our value for A. So A is 3, and let's put that up above. A is 3. Okay? The next step is to find the number of cycles in 360 degrees. So let's see if we can figure that out. Starting at the midline, we have 1 full cycle, and we come back to the midline, decreasing before it starts repeating itself. So that's 1 full cycle. Here's a second full cycle. And let's trace out a third full cycle. And you notice that it took 3 full cycles to get to 360 degrees. And therefore, that will tell you our value of B. So since there are 3 cycles in 360 degrees, that tells us that our B is equal to 3. Let's circle that. Let's put that up here so we don't forget. And this value here is 3. We'll just put it up, squeeze it up there. And finally, we need to look at the shift horizontally. Now, we can look at this as a sine or cosine curve. So why don't we look at it as a cosine curve first, because that's certainly the easiest. And if we look at it as a cosine curve, notice cosines always start at a maximum point and start going down. So notice that then this would be, starting from there, it would look like a cosine curve. And it's been shifted at 90 degrees. You can certainly see that right here. So let's write this all down. Notice I have that here. So the cosine curve is a shift of 90 degrees to the right. And that makes our C equal to 90 degrees. So let's write our equation down, and let's write it neatly over here. So what we do is we say that y is equal to a, which is 3, the cosine of b, which we said was 3, times x minus, and in our case we said it's 90 degrees, and then minus 2, because that's our d value. So there's our equation, and notice that we had a was 3, b happened to be 3 as well, c was 90, and d was negative 2. Now, if we want to look at this as a sine curve, we have to look at where it intersects the midline going up. And the first place it does that is at this point. I'm putting green right here, and it starts going up, but we're not quite sure what that value is. We could figure it out. There's another more obvious point, and that is over here. Notice that at the midline, it is at 180 degrees. It is moving up, and then down, and then up. So you certainly could say one equation for this is it's been shifted over 180 degrees to the right, which would give you our value of c to be 180 degrees. So we certainly could say that if that the sine curve, that c is equal to 180 degrees for the sine curve. And therefore, our equation would be almost identical, but it would look like this. Y equals a, which is 3, the sine of b, which is 3, times x minus 180, because our c is 180 if it's a sine curve, minus 2. And that gives us our two equations for this graph. One is a cosine curve, one is a sine curve. Now, for some of you who would like to be able to figure out another one, we certainly can do that if you think about what the period of this function is. We know that the number of cycles in 360 degrees is equal to 3. Then, in order to find the period, we know that the period, and I'm going to write this up here in red so it's out of the way, the period is always equal to 360 degrees divided by b. And in our case, it's b is equal to 3, so our period is 120 degrees. So that tells us if our period is 120 degrees, or one full cycle in 120 degrees, if I were to go back to our graph and look at where the sine curve, where we had our sine curve shifted to at 180 degrees, and go back one full cycle, that means over here is this distance is 120 degrees, and that's and therefore that point would have to be 180 degrees minus 120, which is 60 degrees. So this point right there would be at 60 degrees, because every full cycle takes 120 degrees. So you could have written actually the sine function as being shifted over to the right only 60 degrees. And if we had done that, we could have said y equals 3, the sine of 3 times x minus 60 degrees minus 2. And that would be just as accurate, because this sine curve has been shifted over 60 degrees. You could think of it that way. You could also think of it as having been shifted over 180 degrees, because that's another full cycle over. And you could keep going. You could say, gee, right here, 100, right at this point, which is another full cycle over, which would be 180 degrees plus another 120. So we could write that, 180 degrees plus 120. That's equal to 300 degrees. So this point right there is at 300 degrees. And we could say that our value for c is 300 degrees. And we could have said y equals 3, the sine of 3 times x minus 300 degrees minus 2. And we could go on like that. So just for the sake of completeness, we said up here the cosine shift was 90. For the sine, we said the shift is 180. But keep in mind, it could also have been only 60. It could also have been 300 degrees. And now it's your turn. Find a sine and a cosine equation for the graph below. So that's it for now. Good luck, and see you again next time.